Blacking iron and steel components at room temperature is so easy with the blackfast system you can do it yourself. And in the next few minutes you'll see just how simple and convenient it is. The real benefits of operating your own blackfast line are lower costs, fast turnaround of finished product, reduction in component stock, and in-house quality control. This video shows you how to set up and run your own blacking line safely and efficiently, and helps you to achieve the best possible black finish for your components. The basic principles of operation are the same throughout the blackfast range. You may have chosen a small 20-litre system for low volume work, or one of the larger lines designed for high volume processing. Whatever system you have, the information in this video is relevant to you. To make things easier, we've divided the video into 4 main sections. The introduction briefly explains the entire blacking process. Installation shows you how to install a blacking line, using a small 20-litre system as an example. Basic training explains each stage of the blacking process in more detail and shows you how to achieve the best results. Finally, modifications for larger blacking lines deals with the slight changes to equipment and procedures which apply to larger blacking lines. The purpose of this introduction is to give you a brief explanation of the blackfast room temperature blacking process. The process can be divided into 3 stages: surface preparation, blacking, and oiling. Surface preparation starts with degreasing, which removes all traces of oil and grease from the metal surface of the component. The component is then rinsed thoroughly in running water and then immersed in conditioner. Conditioner activates the surface, making it ready to receive the blacking solution. After conditioning, the component is rinsed thoroughly again. Now the component is placed in the blacking solution. At the correct strength, the solution will turn a component black in around 30 to 60 seconds. Again, the component is rinsed thoroughly in running water before moving on to the oiling stage. Immersing the component in dewatering oil removes all traces of water and leaves an oily coating on the metal surface. When the component is removed and left to dry, the solvent in the dewatering oil evaporates and the oil is absorbed into the blacked surface. This forms an impenetrable oxygen barrier, giving excellent protection against corrosion. This section shows you how to install a blackfast blacking line. Although we're using a small blacking line to illustrate the process, the same procedures apply throughout the blackfast range. However, there are 1 or 2 differences between large and small lines, and these are dealt with separately in the last section of this video. To operate a small blacking line, all you will need is degreaser, dewatering oil, conditioner, concentrated blacking solution, 7 plastic tanks and lids, 2 baskets, heater mats, tank labels, a thermometer strip, application data sheets, and health and safety documents. Find a permanent site in the factory with access to water and drainage. The blacking line will soon become a vital part of the daily work practice, so it's also important to have ready access to machining areas where components are made. Place the tanks next to each other at a comfortable working height. If the line starts at the left-hand end, the order of tanks is this: degreaser tank, rinse tank, conditioner tank, rinse tank, blacking tank, rinse tank, dewatering oil. At the end of the line, there should be a draining area where components can dry by evaporation of the oil. The heater mats should be placed on a wooden surface underneath the degreasing and blacking tanks. Don't put heating mats in the tanks. Water and drainage should be plumbed into the rinse tanks, with water flowing into the bottom of the tanks and emptying near the top. It's vitally important to have fresh running water in the rinse tanks. The product health and safety documents should be available to the operator. The tank labels are placed to identify each tank and give simple operating instructions. A thermometer strip is placed on the front of the blacking tank, below the level of the liquid. Dilution instructions for the water-based products are on the tank labels and on the application data sheets. Finally, chemicals should be stored indoors and protected from extremes of temperature. Remember to rotate the stock, first in, first out. This section covers each stage of the blacking process in more detail and shows you how to achieve the best results. During this section, you will see a row of small tanks appear at the top of the screen to remind you of where we are in the process. Surface preparation, that's degreasing and conditioning, is the most important stage of all. A metal surface which is completely clean will always turn a uniform black, guaranteed. But a surface which is even slightly oily will end up with a patchy black finish. A small blackfast system will have a room temperature degreaser, which takes between 10 and 20 minutes to clean a lightly oiled, machined component. It's important to check that the surface is completely free of any oil. Wash it thoroughly in water and examine it carefully. Oil on the surface will repel the water, but if you can see a completely unbroken film of water, the surface is now clean. Room temperature degreasers don't work well if the temperature of the solution drops below 15 degrees Celsius. If that happens, a low wattage blackfast heating mat under the tank will gently warm the solution to a good operating temperature of between 16 and 25 degrees Celsius. Keep the degreasing solution clean and up to strength. Skim off any oily scum and top up regularly with fresh degreaser. After degreasing, rinse the component thoroughly in a rinse tank of running water. It's now ready for conditioning. There are two reasons why it's important to condition mild or free-cutting steel. Firstly, the conditioner removes any microscopic contaminants, activates the surface, and prepares it to receive the blacking solution. Secondly, the conditioner lays down a thin phosphate which helps to disguise blemishes in the metal surface. During the conditioning stage, the component changes colour to a dull grey. This usually takes 1 minute. Don't leave the component in for longer than this, or it will affect the subsequent blacking process. Keep the conditioner clean and top up regularly with fresh conditioning solution. Again, rinse the component thoroughly in running water before going on to the blacking stage. A well-prepared metal surface will turn black evenly in around 30 to 60 seconds, although hard steels take a little longer. If your components take much longer than this to black, there are 3 things to check for. First, is the solution up to strength? As components black, they use up the active ingredients in the solution, and so it gets weaker. To keep it working well, test the blacking solution at regular intervals and don't let it drop below 70% of full strength. It's a quick and simple job to test the solution, and clients are supplied with full instructions. Second, has the component been properly cleaned? Experienced operators always take components out of the blacking solution after 10 seconds and inspect them for evidence of poor cleaning. At this stage, any component that's patchy and obviously not properly cleaned can easily be removed and put straight back into the degreaser. Third, is the blacking solution above 15 degrees Celsius? If not, use a blackfast low wattage heating mat under the tank to gently raise the temperature. After 45 to 60 seconds in the solution, the component is checked again. If it has reached about 90% of the desired depth of black, then remove it, as it will continue to darken during the next stage. Taking it out now uses the minimum amount of blacking solution. Leaving it in too long causes over-blacking, sometimes called smutting. A component which has been over-blacked will be covered in a layer of sooty smuts which continuously rub off onto your hands. It's important to avoid over-blacking because the smut acts like a sponge. It soaks up water and blacking chemical which even the best dewatering oil can't get rid of, and this leads to continuous problems and often rusting. Having taken the component out of the blacking solution, it's given a thorough rinse in fresh running water, after which it moves on to the oiling stage. After rinsing, the metal surface of the component is covered in water. Dewatering oil displaces that water and lets it drop to the bottom of the tank. A metal grill in the bottom of the tank keeps the component and the water apart. To enable the water to be drained off, the tank is either tilted or designed with a sloping bottom. In small blacking lines, a separate basket is kept for use only in the oil tank. If not, oily baskets will be reprocessed down the line, contaminating all the other chemicals. In a large system, it isn't practical to transfer components to a different basket, so the same basket is used for the oiling stage, but it must then be degreased thoroughly before being filled with the next load. Different components shed water at different rates. Smooth surfaces dewater relatively quickly. Porous cast iron takes longer. The important thing is that components are completely free of water, and there's no time limit. You can leave them in the oil for as long as you like. A basket full of small items will need to be agitated. Components with holes and complicated shapes will have to be turned over to drain any trapped water. As dewatering oil gets older, it works more slowly and eventually becomes saturated. Its life will be extended by regularly draining the water and topping up the oil. Tanks should have their lids replaced when they're not in use. This is especially important with a dewatering tank to prevent the lighter part of the oil from evaporating. The dewatering oil is the only thing which protects the blacked component from corrosion. The layer of oil forms an impermeable barrier, stopping oxygen from getting to the metal. Any small bubbles on the metal surface mean that water is still present. If the component is left like that, the anti-corrosion barrier will be imperfect, and when the water evaporates, the metal will begin to rust. Before removing components from the oil, check that all the bubbles have disappeared. As the components dry, the solvent in the dewatering oil evaporates, leaving the rest of the oil to be absorbed into the black surface, giving good handling properties and excellent protection from corrosion. To ensure the best possible result, the solvent in the dewatering oil must be allowed to evaporate, leaving the oil relatively dry. In a warm workshop, components can be handled safely within 1 hour, but the black will continue to harden over the following days and weeks. So far, we've looked at installing and operating a small blackfast system. Blackfast lines with tanks holding more than 100 litres, like this one, or this one, are installed and operated using the same principles we've already described. However, there are 1 or 2 differences, and that's what we'll deal with in this section. Larger tanks are made of mild steel with a rubber lining or of polypropylene. Work baskets in large systems are too big to be handled manually, so instead they're moved along the line by an overhead conveyor. To maximise throughput, The degreasing stage is made quicker and more efficient by using a hot degreaser. This tank is different from the others as it's constructed solely from mild steel. This particular tank has a lip extractor fitted to remove any fumes. In larger systems, the conditioning solution is replaced by an acid pickle tank to cope with components of mixed hardness. Hardened steels with surface deposits from the hardening process, gas-impregnated nitrided parts, rusted components, unmachined surfaces, and those with mill scale all need to be pickled in an acid bath. However, if you have blasting facilities available, you should always use them in preference to an acid pickle for removing rust and other contaminants. Cast iron is porous and will absorb most acids. When cleaning cast iron, make sure that you only use blackfast 505. This is a phosphoric acid-based pickle, which has a tendency to seal the surface. Acid clings to metal surfaces, so special care needs to be taken during rinsing to make sure that all the acid is washed away before components go into the blacking tank. Acid pickles containing surfactants cause heavy foaming, which contaminates the other tanks in the line. To prevent this, make sure you use only blackfast NS acid pickle. In larger installations, water rinsing is improved by introducing compressed air into the rinse tanks, creating turbulence. Good rinsing becomes especially important with large workloads. The blacking solution is kept clean by being circulated through a 50-micron filter, removing an iron phosphate precipitate which is formed as a byproduct of the blacking reaction. Another addition is a static hot water dip installed in front of the dewatering oil. Metal components are heated in the water, removed, and then blown dry before being immersed in the dewatering oil. This reduces dewatering time to between 1 and 2 minutes, and the components' drying time to between 5 and 10 minutes. This innovation is essential to maximize throughput. The blackfast line gives its owner the flexibility to process the finished product quickly, at a lower cost and under the supervision of its own in-house quality control. Finished component stocks are reduced and items are blacked on time. The operator works in a clean and safe environment. We at Blackfast Chemicals want to make sure that you achieve the best possible results from your room temperature blacking line. So, if you have any technical questions arising either from this video or from your use of our products, please don't hesitate to contact either your local distributor or us on this fax number.